Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to extend this idea of standard distance to incorporate weights, similar to what we've done with other measures of geographic distribution. And in fact, the equations are going to look pretty similar because we're going to be altering this equation in much the same way that we did the idea of weighted mean. And so what we can do here is we can just take this equation for standard distance, right? Let's do this in blue, right? Let's do it in red. Right, so our new standard distance equation to incorporate this idea of weights is going to look much the same. So we're going to have a square root, just like we did before. And we're going to summate, just like we did before. But what we're going to sum here is this idea of the weight sub I times xi minus x bar squared. And we're going to divide that, instead of by n, we're going to divide by the sum of the weights. Okay? And then we're going to add to that the same thing for the y's, right? The weight times y sub I minus y bar quantity squared over the summation of the weights. Right, and so what this is going to do effectively is this is going to alter this distance to account for some weight. And what will happen, right, is that if the majority of the points closer to the mean have higher values, right, then the standard distance will be lower. If the majority of the points far away from the mean have higher values, then the standard distance is going to be higher, right? So it's going to account for value in the calculation of the standard distance. So just like before, let's go ahead and walk through an example calculation in Excel using this equation. So take a minute, make sure you have this equation copied down so that we can walk through it together. And then we're going to come back and we're going to compare the value we get for weighted standard distance to the calculation that we got for regular standard distance. So let's go ahead and look at this in Excel. So what I have up here, this is the exact same Excel sheet from before. So this top part is going to be the standard distance that we've already calculated. And then down here, what I've done, this is the part we're going to talk about now, where I've included, in addition to the coordinates, I have included this this value column. And this is the exact same data set that we've been working with for every video. So hopefully this should all be the same for you. So one thing that I did here that you may do differently is I've just calculated the regular mean. In reality, if you're doing a weighted standard distance, you may want to take the extra step and use the weighted mean, but I just used the regular mean here because we're focusing more so on the standard distance equation rather than the weighted mean equation. Right? But again, so we're using the standard mean here. You may want to use the weighted mean instead. So let's go ahead and just recap. Right, this part here again is just calculating the average coordinates for x and y. So this is our mean center here. The first two steps are going to look identical, right? We're going to take the value, right, the x sub I, and subtract it from the mean. So this is identical to what we did up here. Same thing with the next step, right? We're going to square that distance. So this is exactly the same as this. So the first two steps in the calculation are exactly the same. The difference is this next step here where we take that squared difference and we multiply it by this weight, which again, in this case is just the value here, right? So we just multiply this number here by this value here to get this. That's all we did, right? It's x minus the mean squared times w. And then same thing for the y, right? Y minus the mean squared times w. Okay, for all of the x's. Then we get to here, and this is just where we sum up, right? We sum up that square difference times the weight, right? We just sum that up, and that's this here. Okay, so this is the first thing that's different because we multiply by w. The second thing that's different is instead of dividing by n, right, we divide by that sum of the weight, right, or the sum of the values. So right here, right, I added up all of the values. So this number right here is just the sum of all of these values. Okay. So then this here is this total, right? This is the sum of the differences squared times weight divided by the sum of the value, right? So if you take this number here, which is the sum of these of all the x's, divided by the sum of the values, you get this number here. And then we do the same thing for the y. Okay, so this is the interior part of the x's and the y's. Next thing is to sum them together. So this is just that plus that. And then finally, we take the square root. So this number right here, this is going to be our weighted standard distance. Okay, so it's 4.12 is our weighted standard distance. And you can see here just in Excel, comparing it to the calculation we did before, right? We have actually altered the standard distance a little bit. And this is because we've incorporated these weights here. And so if we jump back over to our blackboard here, we now have a new weighted distance, and we'll do this in orange, right, of 4.12. Right, and again, we would calculate this the exact same, or we would visualize this the exact same way, right? We would make a circle with the center on the mean feature, the radius equal to the standard distance, and again, this would give a visual interpretation of the distribution, where the larger the circle, the more dispersed the points are. But now we're also incorporating this idea of weight so that you can incorporate, say, population or some other important variable to help determine this distribution. So hopefully this equation made sense. And if you have any questions, as always, please reach out. Thank you.